This is not plastic. This is real metal, 3D printed with a laser, and some of these parts are already flying in aircraft. What you're seeing is not a prototype. This metal 3D printer is already being used in real industries, aerospace, automotive, even medicine. But how does a metal 3D printer actually work? And more importantly, why is metal 3D printing becoming so important? Because what you're about to see is changing how we manufacture things. Let's start simple. This is not your typical 3D printer. Instead of plastic, this metal 3D printer uses metal powder, very fine powder. Materials like titanium, stainless steel, or aluminum. Inside this metal 3D printing machine, a thin layer of powder is spread across a platform. Then a high-powered laser scans the surface and melts the metal exactly where the part needs to be. Once that layer is done, a new one is added, and the process repeats, again and again. Building the part from the ground up, layer by layer, micron by micron. And this is where metal 3D printing becomes really interesting, because engineers are no longer limited by traditional manufacturing. No cutting directions, no molds, no physical constraints. A 3D metal printer allows you to create shapes that were simply impossible before. Internal channels that you can't even see from the outside. Complex geometries that would be impossible to machine. Structures that are strong, but incredibly lightweight. If you're into real industrial technology like this, not just concepts, consider subscribing because I show these types of metal 3D printers up close at trade shows, and this is already happening. Metal 3D printing is being used in aerospace to produce turbine components, parts that are lighter, more efficient, and extremely precise. Even small weight reductions and can save millions over time. But here's the part most people don't realize. This is not just about performance, it's about design freedom. With a metal 3D printer, engineers can rethink parts from scratch. Not how they are made, but how they should exist. And it doesn't stop there. In the medical field, metal 3D printing is used to create custom implants designed for a single patient, matching their exact anatomy. That level of personalization was almost impossible before. Now let's talk about something important, the cost. Because this technology is impressive, but it's not cheap, a metal 3D printer can cost anywhere from 200,000 OEs to over 1 million euros. And that's before you even print your first part. You also need materials, maintenance, energy, and post-processing. Because printing is only part of the process. Many parts still need machining, polishing, or heat treatment. So no, this is not a plug-and-play solution. It requires expertise, infrastructure, and a clear use case. So why are companies investing in metal 3D printing? Because in some cases, it's not just better, it's the only option. Imagine producing a complex part using traditional methods. You might need multiple machines, multiple steps, and assembly. With a 3D metal printer, that same part can be made in one single piece, which means less assembly, fewer failure points, simpler logistics. And then there's inventory. Instead of storing thousands of parts, you store a digital file and print the part when you need it using a metal 3D printing machine. Now here's where it gets even more interesting. Not all metal 3D printing technologies work the same way. The process we've seen is called powder bed fusion. But there are other approaches. For example, the Meltio 3D metal printer uses metal wire instead of powder. The wire is melted using multiple lasers and deposited exactly where needed. This type of metal 3D printing has some advantages. It's safer to handle, it creates less waste, and in many cases, it can be more cost-effective. It can also be combined with robotic arms or CNC machines, which means you can repair parts, add material, or create hybrid manufacturing systems. I actually saw this type of metal 3D printer live at a trade show, and seeing it in person is completely different, because when you see metal being built in real time, you understand how advanced this really is. It doesn't feel experimental, it feels industrial. But let's stay realistic. Metal 3D printing is not replacing traditional manufacturing, at least not anytime soon. For large-scale production, traditional methods are still faster and cheaper. Where a metal 3D printer really shines is in complexity, customization, and low-volume production. So instead of asking if metal 3D printing will replace traditional manufacturing, the better question is, how will they work together? And this is where things are heading, a hybrid future where different technologies are combined. Depending on what you need, you might machine a part, then add features using metal 3D printing, and finish it again with traditional processes. And this opens the door to something even bigger: decentralized manufacturing, producing parts closer to where they are needed, reducing transport, reducing delays, increasing flexibility. Now think about this. If metal 3D printers keep improving, what will manufacturing look like in 10 or 20 years? Will factories become smaller and more distributed? Will we start printing critical components on demand? If you're interested in real industrial technology like this, make sure to subscribe because I show metal 3D printing machines from inside trade shows, along with other cutting-edge innovations like robots and advanced machinery. And now I'm curious, have you ever seen a metal 3D printer in real life? Or do you think metal 3D printing will stay limited to specific industries? Let me know in the comments, because this is not just another machine, this is a different way of manufacturing.